Did you find any others that you need? And then as we go through these, I'll point out to you the mistakes that, that we made on them so we can just be extra careful. So number 8 is a multiplying. Some years I'll get people trying to find a least common denominator. Do you ever have to do that when you multiply or divide? Nope. You can only cancel out common factors. So you can't cancel out like the x and the x squared or anything like that. You just basically have to factor. So x over, I factor that denominator, times I factor the numerator and the denominator. Canceling out common factors then will leave us with 1 over x plus, I canceled out the wrong one, didn't I? X plus 4 cancels, so I have 1 over 4x plus 2 quantity squared. So this answer is correct. I just canceled this out, and I didn't cancel out this. Okay, questions on number 8? And remember, these full solutions are on Blackboard too, okay? And then we're going to see 14, 15, 16, 17, and 20. Okay, so number 14 was one where you were subtracting, and the denominators were the same. So when you're subtracting, you do have to get an LCD, but it's already the same. So you want to subtract, but then this wasn't the answer because there's still a GCF in the numerator. Common factor canceled out to give you 2. Oh, no, it needed 13. Okay, 14, the one next to it. We're adding, so we do have to get an LCD, which was x minus 1, x plus 3. I multiplied this one by x plus 3 over x plus 3, this one by x minus 1 over x minus 1. So distributed the 3x, distributed the 4, combined like terms. Then I tried to factor that. I was looking for a factor pair that multiplied to be negative 36. So if I list them all, and there's not one in there that subtracts to be 13, there's one that adds to 13, but this sign's telling me that they're going to have to subtract. If that sign were a plus, they'd have to add. So it didn't factor any further. Questions on 14. Now the biggest mistake I see on these is some people, and I think it's for your own brain, you'll just throw like an x plus 3 here because you know you have to multiply through. But if you show it to the top, you have to also show it to the bottom. So you either show it or don't. Okay. All right, 15, LCD was both denominators. So we have an x plus 5 and an x minus 3. So I'm going to multiply this one by x minus 3 over x minus 3, this one by x plus 5 over x plus 5. Foil, foil, combine over that common denominator, combine like terms, and then factor if you can. So the numerator, a 2 factored out. How did that one go? Okay. And then 16, it's going to be similar to 15, but now there's an additional step. You had to factor and factor. And now the LCD is going to be x plus 4, x plus 3, x plus 2. I already have the x plus 3, so it's all 3 of those. So the first one's missing the x plus 2. The second one's missing the x plus 4. Now this one we have to be real careful. This minus sign causes problems, okay? So put parentheses, so that you know that you're going to have to distribute it. And once you FOIL it, you'll have to distribute it through the numerator and then combine like terms to get the answer. Any questions? If you made a mistake, are you finding it?
So there's a question that's incorrect that's like 9 minus y or 3 minus y. If that's the case, like would we still be able to
Yeah, I do. Okay. So let's say your answer, I don't know, you have some problem, you have some LCD, who knows what it is, but let's say you have 3 minus y. Could you write it negative y plus 3? Could you write it negative quantity y minus 3? Could you write it negative quantity negative 3 plus y? All of those would be absolutely fine. Okay? Did that answer it?
But like if it's the denominator, and it's like 3 plus y times 4 plus y.
Okay.
Would that still be the LCD, or would we have to do since it's just the opposite of like y minus 3?
Oh, okay. I think I know what you mean. If you have y minus 3 and 3 minus y. Is that what you mean? Okay. So no, I would not take both. What would we do to this one? Yeah, if you notice that the signs are all opposites, pull out a negative. That'll make this a subtraction instead of a positive. And then the denominators are the same. Okay? Yeah, I don't know if they gave you one on here, did they? No, we can look back at one like that because that's a good question. Okay, number 17 was also asked, and then I'll find one like the one that she's asking because that's a good one to take a look at. This one you had to factor just the third denominator. So the only common denominator, you don't want all four. X minus 4 is in both of these, only to the first power, x plus 4 to the first. So I multiplied this first one by x plus 4 over x plus 4, the second one by x minus 4 over x minus 4, and the third one by nothing, okay, because it was okay how it was. And then when I FOIL, here's where the mistake comes in on this one. Distributing the minus to get minus x squared plus 4x. So just be careful. And then a lot of times we'll get to this step, we'll forget that we need to keep going. So this one in 8 factors out, and then you can get the final answer. Okay, any questions on that one? Okay. All right, 18 I think was like the one that had the most work. 18, you had to factor by grouping each of those denominators. So see if the first one you factored was x minus 7, 3x minus 1, 3x minus 1, x plus 7. Do you see how factoring becomes such a small part of the problem? We can't even do the addition until we have those factored. So our LCD is all 3 different quantities. This first fraction was only missing the x plus 7. The second fraction was only missing the x minus 7. So I'm going to FOIL, and here's where the mistake can be made. So be careful. Negative that quantity, we'll have to distribute that minus, and then a lot of stuff will cancel out to give us 28x. Okay, so I'll leave that one up for a minute while I find one like Sydney just asked about. Okay, any questions on that one? Okay, the last one was 20. So number 20, this is when you have a complex fraction. So a complex fraction actually takes everything we've done in the unit and throws it into one problem. So what you're going to do on the top is find your LCD, like we did in section 5, build equivalent fractions like we did in section 6, subtract like we did in section 4, okay? And then the same thing in the denominator. So it's like 2 mini problems. And then we make it a section 3 problem where we change the division to multiplication and invert the divisor. And then it becomes a section 2 problem where we have to factor and cancel out common factors. So one like that has it all. Now they're normally easier ones, like you typically won't see denominators like we did in number 18 when you have a complex fraction, because they're just longer problems anyways. Anything else diagnostic test? Do okay? Yep. And then I'm going to show you one. I'm going to have you try one because this was a great question. Let's try 4x over 4 minus y. Actually, let's make it 4 minus x. Minus 8 over x minus 4. What is the LCD? You could do x minus 4, or you could do 4 minus x. Okay, either way would work. The way I typically do is I want to make that second, I want to work on the second fraction because I find it's easier to have signs in the middle as opposed to signs in the front. So when I do this one, I'm going to factor out the negative in the second one. So then the first fraction stays the same. Minus and a minus become positive, yeah. So then this is going to be 8 over 4 minus x. And then we'll get 4x plus 8 over 4 minus x. And then we can factor to see if anything will simplify. This one, nothing simplified, but the factored form's like the most simple way to write it. Yeah, question?
If we change the sign to a positive, why would the 8 be negative?
Okay, because what happened, since I just factored out a negative out of the bottom, it is like this negative, if I wanted, could go out in front of the fraction. It only changes the top or the bottom, because if you multiplied both by -1, it would be +1. Okay, so what I'll do is just think of this being a minus times a minus, and that's why that changes to a plus. If I would also do it to the -8, I would be multiplying by a negative times a negative, which is a positive. Okay? Other questions? Okay, so we're going to do a tiny little sneak peek of what's coming up next. We're going to start trig on Monday. Okay, so in order to start trig on Monday, there are some things from algebra that, or from geometry actually, that you need to remember. And it's been a little while, so you probably don't remember it crystal clear. Anyone taking SATs, college entrance exams, these are on it. Okay, so it's a really good review whether, we're doing trig or whether you're just testing. What I did on the front of this little worksheet is put those special triangle relationships, and you have to memorize them. I mean, there's really not another way to do it other than memorize them. In geometry, you kind of develop them and you figured out why they work that way. But when you have a 45, 45, 90 right triangle, give me another name for that right triangle. If two sides are equal, it's called isosceles. Remember that? Okay, so it's called isosceles if two sides are equal. What if three sides are equal? Equilateral. Okay, so this is isosceles. So if you would know the side, let's say this side's 5. Do you know what this side is? 5. Now you could use the Pythagorean theorem, right? But the shortcut is it's always going to be that side times root 2. So what would this answer be if these are 5? 5 root 2. Okay. What if they give you the hypotenuse, 5 root 2? How would you go backwards to find the sides? We multiplied to get root 2, so how do you go from x root 2 to x? Divide by root 2, okay? So we're going to end up with some things like, let's say we make this a 3. If we make the hypotenuse a 3, what will the legs be? And we're going to have to memorize if these sides, if we know these sides, we multiply by root 2. If you know the hypotenuse,
3 over root 2.
Yeah. And then what are we going to have to do? Yes, so we always have to rationalize. So that was something you did in geometry, okay? But that's what we're going to have to make sure you know so we can actually do the trig. The other special right triangle is the 30, 60, 90, okay? I memorize this weirdly, so however you need to memorize it. I always know the base side that I always want to know is the side across from the 30, because it's the x. It's the nicest number of the bunch. To get the hypotenuse, you double whatever that number is. To get the long leg, because remember in geometry, if you have a 30-degree angle, this side is going to be shorter than the side across from the 60. So this is called the long leg, and this is called the short leg. So let's say the short leg's 5. If this is 5, what would the hypotenuse be? 10. And I always want this one because it always builds off of this one. What is this side? 5 root 3, okay? So what if they gave you the hypotenuse? What would you do to get this one? Divide by 2 and then multiply that side by root 3. The hardest case is when they give you this side, the long leg.
You divide by root 3, then you get
Yes.
the short leg, and then you multiply by 2.
Exactly. So let me give you a harder one, okay? Let me give you that this side is 5. Okay, so if the long leg's 5, how am I going to get the short leg? Divide by root 3. And then you have to rationalize it, right? If you know the short leg, what do you do to get the hypotenuse? Multiply by 2. Now, when you multiply by 2, it's 2 over 1. So this will be 10 root 3 over 3. The root 3 and the 3 don't change. It's the 5 times 2. Okay, so what you'll see on tomorrow night as the homework, there is a I think it's 5 minutes, maybe less, video going through, because your homework's going to be this first page, worksheet 1. And in the video, I do like 5 of them or something, and just to review how to do them. Now, if you're doing them and you're checking your answers and you're getting them right, then you know how to do it. But there are going to be some people, like I know some people know already because they were saying the answers. Some people are like, ooh, this has been a while. Okay, so that's what the homework is tomorrow. We need this before we can even think of talking about trig. So if you don't know these, trig is going to be really tough at the beginning. Well, it's going to be really tough because it's all based off of these. Okay? Any questions? Okay, so homework for tonight is study for the test. What does that mean for you? If you did the diagnostic test and you didn't miss any, you might really not have to do anything. Okay? If you missed on the diagnostic test certain ones, you may want to find the ones that look like that on pages 15 and 16 and do. You may choose to do all the evens on 15 and 16 just to extra review yourself. Okay? So whatever you need to do, but just make sure you're ready for the test. So it's just a free night to study, get ready. If you need some problems to do, I told you which ones you could do. And I'm sorry, we didn't have time to do the quiz. So those of you that are going to do the retake, if I didn't give you a pass yet, just let me know and I'll give you a pass.